Hello friends, I'm Professor Maheshinde. Yesterday, in part 1, we have started the chapter Sound and Acoustics and Sound Insulation. We have covered few of the points from this chapter, just like few definitions like frequency, pitch, loudness, no, intensity of sound, the measurement of sound, behavior of sound. Based on that, again, we have covered few tables that rating of intensity levels of sound and the indoor noise acceptable levels that we have covered in yesterday's part. Let's start in continuation in today's part. These are the definitions that we have covered in first part. So moving to the next one is acoustical defects. This is very important point. Acoustical defects. Remember, a perfect acoustic conditions in room or in auditorium are obtained when an average sound rises to a suitable intensity in every part of auditorium with no echoes or no distortion of original sound and then dies out quickly enough so as so as there is no interfere with succeeding sounds. Important one. To achieve this in practice, one has to remove or minimize all defects in acoustic. So you have to consider suitable intensity of sound and an acceptable level of reverberations. Is it? So to have this, the defects that we have to focus more, the considered in the planning are: first defect is the echoes, formation of echoes; second, reverberation; third, sound foci; fourth, dead spot; fifth, insufficient loudness; and fourth one is exterior noise or indoor noise, like this. So let's start one by one discussion. The echoes or formation of echoes. See the points mentioned on the slide. An echo is produced or formed when a reflected sound wave coming from the same source reaches the ear just when a direct sound is already heard, and thus there is a repetition. A repetition of same sound is nothing but the echo. Repetition of same sound is nothing but the echo. Just hearing the direct sound, if you hear same sound again, it means echo is formed. It may be that sound is reflected from some surface to your ears. Already you have directly heard the sound wave, but again same sound is reflected from any other surface and you are listening it to again same sound. It means echo is formed. In other words, we can say echo is an indirect or reflected voice which is heard just after the direct hearing of the voice coming from the same sound source. The formation of echoes normally happens when the time lag between the two voices or sound is about 1 by 17th of a second, and the reflecting surfaces are situated at a distance greater than 15 meters. If reflecting surfaces are more than a distance of 15 meters and the gap is between less than we can say 1 by 17th of second, then echo will form. The defect usually occurs when the shape of reflected surface is curved. Mostly chances are when the surface are curved, the echoes are formed. With smooth character means surfaces, again texture, instead of hard, it is, if texture is smooth, again there is possibility of formation of echo. Echoes causes disturbance and unpleasant hearing. So if echo is forming, you cannot hear new sentence or new sound. You are listening same sound again and again and again, so it becomes unpleasant, hearing becomes unpleasant. So the remedy of this defect is, what is the remedy for this one? So select the proper shape, give the proper shape, and surfaces. So just I told you about curved surfaces. Avoid it. Smooth surface. Avoid it. So go for the rough one. Porous material. Use porous materials. Use rough surfaces and avoid the curve shapes. Simple. So you have to means disperse the energy of echoes. So to disperse this energy of echoes, use the flat surfaces, use the porous surfaces or rough surfaces. So this is from the echoes. Next one is the reverberation. Again, this is very important. Reverberation. See what is reverberation? The produced sound wave after being reflected after being reflected a part only, the remaining part is absorbed by surfaces in the form of heat energy, which has been converted from sound energy by friction. So I would like to keep in this bracket. So the produced sound waves after being reflected on the surfaces result in the formation of echoes. But this reflection of sound waves does not stop even if the source producing them has ceased or died out after it has once started or taken place. That is reverberation. The sound is reflected back and forth against the null ceilings and floors several times even after the source has died out. This particularly happens when any sound which originates in or enters a closed space is successively reflected by the smooth boundaries of the enclosed space again and again and again. So that sound reflected remains there. Under such circumstances, either very little or no energy is lost in multiple reflections, and therefore the echoes will build up to a maximum intensity. Means maybe possibility that there is a smooth surfaces, so sound is again and again reflecting, but no sound energy is getting absorbed. So if sound energy not absorbed, again you will hear same sound. If same sound is here, echo will form. This is the condition. So this prolongation of sound after the source producing it has died out is called as reverberation. Means the original sound prolongates in the air in the room after the source producing to that sound is died out. If such thing happens, it is called as reverberation. Very important. So certain amount of reverberation is of course desirable for improving the qualities of sound, whereas too large a reverberation creates confusion in hearing because echoes will form. The remedy of this defect lies in selecting a correct time of reverberation known as optimum time of reverberation. So for the designing we have to get to this bit, that is optimum time of reverberation. If you able to calculate this one, so you can achieve 50% acoustical treatment here. So this optimum reverberation time, it can be achieved by suitably using the absorbent or acoustical materials. So you have to go for the use of absorbent or acoustical materials or different reflecting surfaces. As the reverberation refers to period of prolongation, so it can be measured quantitatively by the length of time required for the sound to become the audible after stopping the source. Means if you able to calculate the length of sound and what time is required to for that sound after the uh, source has originated, so you can calculate the reverberation. So I can say here reverberation time is the period of time in second which is required for sound energy to decay or diminish by 60 decibels after sound source has stopped. After sound source has stopped. So Sabin's formula is used to calculate the reverberation time. Here reverberation time shows t greater than 5 seconds. If such conditions occur, the time of sound waves is greater than 5 seconds, then this is very bad. If it is between 3 to 5 seconds, this is bad condition. If it is between 2 seconds to 3 seconds, fairly good. If it is between 1.5 to 2, it is good. And if it is between 0.5 to 1.5 second, it is very good. So we have to focus on bottom two one, very good and good conditions. Means try to achieve the length of sound reverberation time between 0.5 second, half second to maximum 2 second. If you achieve this condition, so this condition will be very good or good condition. So reverberation should be short for auditorium or cinema theaters, public, any public addresses or recreation halls or halls there. So this is important one. So Sabin's formula is used to calculate this one. So I'll orally explain what is Sabin's formula, how reverberation time is calculated. So Sabin's formula is used reverberation time T. So I'll assume T is as a reverberation time. It is calculated as T is equal to 0.16 into V, capital V, divided by A1, capital A1 S1 plus A2 S2 plus A3 S3. So what is V? So V is the volume of the room in cubic meter, meter cube. V is the volume of room. T is the time of reverberation in second. And what is A1 S1? A1 S1. A1 is the coefficient of absorption of individual unit. So individual unit. So we can consider the walls, ceilings, floors, whatever materials are there, whatever elements of building are there, which are present in that sound room. So those we will consider here. So this is the coefficients of absorption of that individual unit. And what is S1? S1 is the area of absorbing surface. If I consider the individual unit is ceiling, so I'll consider the S1 is the area of ceiling. So this area of ceiling is taken to be meter square. If I consider the coefficient of absorption as a floor or as a wall, so I'll consider S2 as a area wall like this. So it is in meter square. This is how Sabin's formula used for the calculation of reverberation time. So very important. Normally optimum reverberation time for cinema theaters are achieved between 1.3 to 1.5 second. Just now we have seen that reverberation time more than 0.5 second and should not be more than 2 second will be good and very good. So in cinema theaters are accordingly planned 1.3 to 1.5 second. If churches are there, you can take it at 1.8 to 3 second, maximum 3 second, because the volume of church increases, height is more, so comparatively there is chances of sound takes more time, so it goes to the 3 second. Then your conference rooms are there, committee rooms are there, so again you can take same 1 to 1.5 second. Normally music halls are there, normally 1.5 to 2 second or 1.6 to 2 second. Parliament house same 1 to 1.5 second. Public lecture halls 1.5 to 2 second. A very large hall 2 to 3 second maximum, like this. So these optimum reverberation times may be used. There are absorption coefficient. Just we have seen Sabin's formula. Absorption coefficients are mentioned there. So I told you 0.16 V upon A1 S1 plus A2 S2 plus A3 S3 and so on. So here all A1, A2, A3, A4, all these are the coefficients of absorption of individual unit. So for example, suppose in that room window present, so absorption coefficient is 1. Ventilator present, so coefficient is 0.1 to 0.5. Stage curtain is there, it is 0.02. Marble is there, 0.01. Window glaze is there, 0.118. So for all those materials different absorption coefficients are present, and those are mentioned in IS code. Is it? So this is important one. Next, important defect in the acoustics is the sound foci. What is sound foci? In case of concave shaped reflecting interior surface or domed ceilings of an enclosure, depending upon the curvature of this surface, there is the possibility for reflected sound rays to meet at a common point called as sound focus. This causes concentration effect of the reflective echoes and consequently creates a sound of large intensity. These spots of unusual loudness or intensity are known as sound foci. These are the sound foci. These defects can be eliminated by providing suitably designed geometric shapes. Geometry, if you go for the different geometric shape, this defect can be removed. So same thing here mentioned here. When reflected sound rays meet at a common point which causes the concentration effect is nothing but the simply sound foci. Next one is the dead spot. What is dead spot? This is again one important. If sound foci occurs in any room, in short I will tell you, if sound foci occurs, there is 100% chances of occurring of dead spot. Because in sound foci what happens? Sound energy or sound rays meet or concentrate in a common point. So because of sound energy, maximum sound energy concentrated in that point or in that portion of the room, other portions of the room remain vacant because sound energy cannot travel to those portions. If sound energy do not reach to those portions, it becomes a dead spot. So sound foci present, it means dead spot is also present. So in short we can say side effect of sound foci, it is a dead spot. Deficiency of reflected sound rays causes low sound intensity at some points. So if the reflected sound rays do not reach in all the portions in all the space of the room, so dead spot will present. And the last acoustical defect is insufficient loudness. So in case of theaters, buildings and large auditoriums, it is acoustically desirable that speakers' voice or music from stage should be easily audible in all parts of the hall at uniform intensity of loudness. As we have seen the screens and cinema theaters, from the curtain, the length of hall is more. So the person sitting at the first row, how much time is required for that person to listen the sound of cinema? Same time should be required by the person sitting at the last row. So if with same uniform velocity, so if you manage this one, so there will not be any insufficient loudness. So there will be proper loudness. To achieve this, the sound waves should get properly reflected and uniformly spread all over the interior of the enclosure. But the lack of sound reflecting flat surfaces near the sound source or stage and excessive absorption of sound in the halls result in the defects of insufficient loudness. This defect we can remove or we can rectify it by arranging the hard reflective surfaces near the stage. Where is sound source, we can use the hard reflecting surfaces and we can amplify the sound or sound source, and also by providing absorption of the hall such as amount that an optimum time of reverberation can be assured. Many times if more absorption surfaces are there, we have to avoid it so that reverberation time can be achieved, optimum reverberation time can be achieved like this. Or sometimes we have to go for the amplifiers. This usually achieved by employing other measures as well, such as use of loudspeakers or use for larger length of halls, or by limiting the length of hall, or you can reduce the length of hall also. The depth of balcony space should be more than 2 to 3 times of the front height leading to it. The location of loudspeaker, if used, should be carefully adjusted so as not to cause sound fuzzy and dead spot. So this is very important in the auditorium. There should not be any insufficient loudness. So friends, today we stop here. This will be a second part of your acoustics. Thank you.